All right, we are back with another video on doing some math problems. This time we are going to be going over the shell method and finding cylindrical volumes with the shell method via integration. The shell method involves integration. I mean, those two and two go together. Anyways, we're just going to be doing some problems. We'll do 3 in this video, and I'll show you guys how to do them. If you guys are coming to this video, I'm going to be under the assumption that you guys know like the concept of the shell method and what it's entailing. You know the concept of cylindrical volume. You know the concept of how we rotate a solid in a 2D plane to find the volume of it, and we use integration to find that volume. So in this video, I'm just going to be really just showing you the problem solving of how to do these problems. I'm doing this because this is going to strengthen my own skills for my Calculus 2 class, and also I just want to help you guys out. So yeah, let's get started on this. So the first problem. So we have a solid that is obtained by rotating the shaded region about the specified line. So again, in concept, this shaded area that basically we're kind of finding the integral of, but not really. We're going to imagine rotating this in the 2D plane. It will make like a 3D shape. And we want to find the volume of that shape. So that's where we have to use our shell method, right? So first things first. The shell method is a formula that you have to memorize, right? So shell method, right? The shell method formula goes like this. The volume. I know I said that I was not going to go through like the concept, but I just want to do a quick recap of the concept so it's easier to solve the problem. So the volume, which you see right here, is when this thing is going to be rotated around a specific axis, which is about the y-axis. So imagine this y-axis and it rotates around. That volume is going to equal to 2 pi, right? That's our constant. And the integral with bounds from a to b, the point radius, which I will explain what that is, times f of x, which is the top function, minus g of x, which is the bottom function. And in this formula, it's in respect to dx, right? So sometimes you'll get problems where you're going to have to put it in the y, which I'll show you. But this is the formula, right? F of x minus g of x can also be seen as, height in some formulas. But I like to remember it like this because it's easier for me and it's easier to know how to problem solve like that. So this is the shell method formula that you will always have to constantly be applying. So let's solve this problem. So a solid is obtained by rotating the shaded region about the specified line. I cannot read. And it's about the y-axis, right? So we have, I think it'll be easier for me if no, I'm recording. I'm silly. Here, I think I have an idea. We're gonna take a screenshot of this and we're just gonna put it right here. It's gonna be much easier to just play around and graph with this thing. Okay, so we have our y-axis. We have a parabola going about here, which is y equals 3x minus x squared, right? This is the parabola. And then we have just a straight linear line of y equals x. So this is an unlabeled graph and we don't know the bounds. So to find the bounds, and since we know that it's going to be in terms of d of x since we are rotating about the y-axis, we want to set these two functions equal to each other, right? To find where they intersect at this point so that we can find that x value that goes over here. We know this is going to be 0 as determined right there. Okay, so we're going to do 3x minus x squared equals x. Okay, now we just want to basically just solve it out, find x. So we can move x over to this side, so minus x, and this will give us negative x squared plus 2x equals 0. Then we just want to factor an x out, so we'll have x times negative x plus 2 equals 0. So now we can solve. So the first x right here, so right here to right here, that is not a good arrow, right here to right here, that x is going to equal to 0. Okay, so because if you were to solve for x equals 0 and got rid of these parentheses, x equals 0, yeah? So that's going to be our lower bound, which is already given. To find our upper bound, we're going to be doing negative x plus 2 equals 0, minus 2 on each side. You have negative x equals negative 2. Divide the negative on each side, and at the end of that all, you should get x equals 2. So your bounds are going to be from 0 to 2. So we're going to put that here. All right, so we found our bounds. Now we can actually get to setting up this problem, actually. So first we want to find the point radius. What exactly is the point radius? Basically, how I like to think of it and how I was taught by my professor, just plot any point in this shaded region, and we're going to label that x, since we are working in terms of x because we're rotating of the y-axis. And we want to find the radius, aka the distance from this point to whatever axis we are rotating by. And since we're rotating by the y-axis, y is going to equal 0, right? So y equals 0. So when we put this out, right? Actually, I can just like make one big arrow here. The point radius is going to be x minus 0. Okay? Because it's x, point from here, and its distance from y equals 0, which is 0. And x minus 0 is, well, x. So our point radius is going to be x in this equation. So we're going to just move down here. And for reference sake, for the easiness, if that's even a word, for everyone involved, we're just going to copy and paste this formula down here. Okay, so we now know our point radius. Let's start filling this thing out. And by the way, in this problem, notice that they didn't put out the 2 pi constant, so we're going to have to put that ourselves. So 2 pi. So let's write this. So v equals, from the bounds of 0 to 2 pi, and we know our point radius is x, times So let's put this in brackets. This is like a separate thing. Times our top and bottom function. What's our top function? 3x minus x squared. So this would be 3x minus x squared minus our bottom function, x, in respect to dx. So x, and then this would be 3x minus x squared minus, oops, let's put that there, minus x. So that should be our integral that we set up. I know that I only have 2 submissions on this, but let's just use one. It says I got this wrong because I didn't put an answer in, but as you can see here, we got this correct, right? So we're putting that, excuse me for the box, but that is the answer for that. We have just set up this integral. That looks like it needs to be simplified a little more. So let's do that. So if we want to even like evaluate this thing, so let's put this over here. So v equals, let's take that constant out because I hate constants just inside the integral. It's just like gives me the ick. So 0 to 2 x times all of this stuff minus x in respect to dx. Okay, cool. Now let's solve whatever is inside of this. This looks like a hot mess. This would be x times, because 3x and x and minus x, that's going to be 2x minus x squared dx, 0 to 2, 2 pi, volume, right? And then we're going to multiply this one here and this one here. So that will end up being volume equals 2 pi from the bounds of 0 to 2, 2x squared minus x cubed dx. That looks very, very integratable. Very nice. Yeah. So then we'll have volume equals 2 pi, and let's integrate this thing, right? So we got 2x cubed over 3. I'm assuming you guys like know the integral rules. I mean, it's just x over n plus 1 over n plus 1. It's like if you're integrating like a constant. I'm assuming if you're watching this video, you know that, because if you don't know how to integrate, you probably can't do these problems. Though I'm not the best at math, so sometimes I mess up my integration too. I can't be talking. So x to the 4th over 4. And in respect to 0 to 2. Cool. So now we just got to plug this all in. So v equals 2 pi times 2 to the 3rd over 3 minus 2 to the 4th over 4. Minus 0. Okay, we're gonna put this in our handy dandy calculator here. So I'm gonna try to speed this up and actually putting it in, because this is not the hard part. All right, we have 2 pi 4 over 3 minus 0. And 4 times 2 is 8. So then our final volume should be 8 pi over 3. I'm not very confident in my own math, I'll be honest with you. I hope I don't get it wrong. All right, there you go. Yeah, I am not the best at math, and I make these videos so that it helps me just go over and learn for myself. And I mean, I like making videos and stuff. But yeah, so that is our final answer for this entire problem. So yeah, we're gonna go on to the next problem. Cool. All right. So you can ignore this screen and stuff. I've already answered this problem, so I'm actually gonna check myself, see if I did it right on this. It's problem number 2, but you can ignore this screen for now. All right. Use the method of cylindrical shells to find the volume generated by rotating the region bounded in a given curve about the y-axis. So again, we are rotating about the y-axis, so everything will be in terms of dx, okay? So we just got to put that straight, right? So y-axis will be, put terms in d of x. Okay, so what do we have here? We have our upper bound and our lower bound. We have, first, before anything actually, we gotta write our shell method, right? And our shell method is volume equals 2 pi to the integral of a to b, point radius times f of x minus g of x dx. In this case, we are using dx. Okay, so let's graph this thing. All right. So we're given y equals 0, which is this. We're given that x equals 9, which is this. And then we're given y is equal to the square root of x, which is going to look like this. Cool. Okay. We're rotating it about the y-axis. So let's get to that. First, we want to find our point radius, is right here, right? So our point radius will be, well, since there is no specified y-axis number, it's just going to be x equals 0. I'm going to check something real quick. Okay. It's going to be x equals 0. So because, well, wait, I am tripping. X minus 0. I'm sorry. I was thinking ahead of myself. X minus 0, which is then our point radius equals to x. Okay. So let's put that all in. So we have our volume. Oh, and this is y equals square root of x. Okay. We have our volume, which is equal to 2 pi from bounds from 0 to 9 x times square root of x minus 0, because the other y function that we're given is y equals 0, which is down here. So this is our top right here, and this is our bottom. And that is going to be in respect to dx. Cool. So now what we're going to do is we are going to make this look a little simpler. So volume equals 2 pi bounds of 0 to 9 x times square root of x. We don't like square roots, okay? So we're gonna put this into the power of 1/2 instead. So let's rewrite it again. So 2 pi to the bounds of 0 to 9 x times x to the power of 1/2. And if you know anything about multiplying, or well, yeah, multiplying exponents, you know that they just get added. So think of this here as being 2 over 2. So then finally, we'll have 2 pi to the bounds of 0 to 9 x to 3 over 2, oops, in respect to dx. Cool. So now this looks very integratable. So volume equals 2 pi, let's integrate this thing. Well, we can just do 3 over 2 plus 2 over 2 because that is 1. So x to the 5 halves over 5 halves in bounds of 0 to 9. So then volume will equal 2 pi 9 to the power of 5 over 2 over 5 over 2 minus 0, obviously. And let's use our calculator for this. So we'll have 9 to the power of 5 over 2, that over 5 over 2. 486 over 5, and then 486. So let's write that down. This volume equals 2 pi 486 over 5. 46 times 2 is 972. So we'll have the final answer being 972 pi over 5. I hope I'm right. There you go. Yep, that is our final answer. 972 pi over 5. Okay, so that was the solution for this problem using the shell method. We have one more problem. If I get lucky, then I might get it, and that would be kind of cool. This time, you see that? We're rotating it about the x-axis, and that means we got to put it in terms of dy. So this got to be in terms of dy, meaning we got to turn these y functions, we got to basically turn these into like f of y functions, right? So we got to make these equal to x. So let's graph this first. So we have right here, we have y equals x cubed, okay? Y equals 27, x equals 0. So x equals 0 is going to be our y-axis. So this is x equals 0. Y equals 27 is going to be this straight line right here. We're just going to call this y equals 27. And then we have y equals x cubed, which is going to look something like this. All right. Right, so because we're rotating it about the x-axis, to be honest, what I would like to do, since we still are managing with the shell method, because remember, shell method, gotta write this down all the time. Volume equals 2 pi to the bounds of a to b point radius times f of x minus g of x in respect to dx, and this problem is dy, with this being the top, with this being the bottom, which is why, because since we're doing it about the x-axis, it would be easier to kind of think of it in a rotated way when we're talking about what is top and what is bottom. So since we're rotating about the x-axis, our bounds are actually already given. We're going to start from 0, but because we're doing it in respect to dy, this y, which is y equals 27, that's already a given, which means that our bounds for this problem are going to be from 0 to 27. So 2 pi from 0 to 27. So let's find our point radius now. So let's like rotate this around. We have our x equals 0 here. I know it's kind of weird to think about like rotating it and like, you know, I know it's kind of weird like that. Like, I know. Then we have, let's see here. We have our function. I have to turn my head sideways for this. This is our very well drawn. Oh, that is a very terrible draw. I am sorry, guys. Give me 1 second. Okay, this is the best I can do. This is our very well drawn y equals x cubed. I forgot to write it up here. Y equals x cubed. And then we have our y equals 27, and we have 0 here, right? We're wanting to find the rotational volume of this area. We want to rotate this around, you know. Okay, so our point radius. Smack this right here, which is just going to be our arbitrary y. And we're going to see how far it is from the x-axis, which, by the way, this is the x-axis, and in our new rotated way, this is our x-axis. This is how I solve the problem, at least. This is absolutely by any means, you do not have to do what I do. This is how I like thinking of it, to make it more intuitive for myself when I problem solve. So this is going to be from basically y, so PR, y minus 0. What's that equal to? Well, that equals to y. Cool. So our point radius is y. But remember, like I said a little earlier ago, that we cannot put these in x. We can't just slap in x in here. We have to make these into y, right? So let's solve for x for this one, right? So we're gonna go over here. So x cubed equals y. And then if you want to get rid of this x cubed, you got to put a cube root on each side. So our final thing this is going to turn into, so we can like erase this, it's going to be x equals cube root of y. So this will turn into the cube root of y. That's our top function, and our bottom function is going to be, well, 0, because x equals 0. So minus 0 in respect to dy. And I think that problem said to not evaluate the integral and just create it. So let's see if we got it right. Yeah, we did. Technically, because this problem, it didn't put the 2 pi constant over here, we still did it. I mean, you don't even have to write this minus 0. You really could just write it if you really want it, put this constant inside of here, which on WebAssign, it makes you do that. So the final answer would be 0 to 27 y times the cube root of y dy 2 pi. Keep forgetting it. But yeah, that would be our answer for that. So that is 3 problems involving cylindrical shells. Solve them all. So yeah, that's the video. We're heading on to 30 minutes and I still have not finished my vanilla protein thing. I was so bogged down with making this video. If you stuck all the way through the end, that is very nice. That's very cool. I wonder if there's any students from my university watching this, and if you are, I mean, I'm struggling in Calc 2 like you guys. I just, So yeah, thank you guys for watching the video. I really hope that you guys enjoyed this video and got something out of it. These videos are really mainly to help myself, but nevertheless, I do enjoy taking the time to work these problems out also. So yeah, thank you guys for watching the video, and I will see you guys soon in another video. Bye bye.